Hi, this is Dr. Xu teaching mine ventilation for mining engineering college students. Today we will talk about mine gases and gas laws. Numerous gases may be produced in the underground mine environment as part of the mining process, from strata or during mine fires and spontaneous combustion events. Hazards associated with these gases range from simple displacement of oxygen by inert gases to explosive and or toxic mixtures. As shown on this slide, the toxic gases include ammonia, carbon monoxide, carbon dioxide, hydrogen sulfide, nitrogen dioxide, nitrous oxide, sulfur dioxide. And the flammable gases include hydrogen, methane, carbon monoxide, and hydrogen sulfide. As typical air density is about 1.2 kilogram per cubic meter, some of these gases are lighter, so they accumulate on the roof, and other gases are heavier, so their concentration is more near the floor. One source of gas in underground is from the combustion processes, such as the running of diesel equipment, the use of explosives, oxidation of sulfide ores, and mine fire products. These processes not only produce gases but also reduce underground oxygen content. Gas emission from strata is another source of mine gases. One of the common problems is the emission of methane and carbon dioxide from coal seams, and radon emission from uranium mines. Other gas sources include the emission of hydrogen and chlorine from battery charging, various gases and fume emissions from underground workshops, and the emission of ammonia from underground refrigeration plants. Exposure to toxic gases is a combination effect of gas concentration, duration of exposure, and an individual's susceptibility to any harmful effects. Take carbon monoxide for example. At concentration of 400 ppm, exposure for less than 30 minutes results in no effect, but for more than 3 hours may cause unconsciousness and dangerous to life. Threshold limit values are used as concentration limits below which workers may be exposed without adverse effects. These are internationally recognized standards based on recommendations of the American Conference of Governmental Industrial Hygienists and the U.S. National Institute for Occupational Safety and Health. There are three commonly used threshold limit values: the time-weighted average TWA, the short-term exposure limit STEL, and ceiling C. The time-weighted average is the concentration to which most workers can be repeatedly exposed for a normal 8 hours shift per day, assuming 40 hours per week, without adverse effects. To obtain the TWA value, first calculate the accumulative dose, which is the sum of the exposure concentration by exposure time, and then divide the dose by 8 hours. Here is always 8 hours because we want to calculate the equivalent TWA. It doesn't matter how many hours the worker has worked for, we always convert it to 8 hours equivalent. Let's look at this example. In a 12-hour shift, a worker spent 1 hour in areas with negligible CO concentrations, 6 hours in area with 35 part per million CO, and 5 hours with 25 part per million CO. Is this acceptable if the TWA for CO is 30? So firstly, we calculate the total dose. The dose equals to, there is 0 concentration for 1 hour, and 35 ppm for 6 hours, and 25 ppm for 5 hours. The result is 335 ppm hour. We can see that the worker has worked for 12 hours, but we will need to convert it to an 8-hour equivalent. So the equivalent TWA equals to dose divided by 8 hours. So that is 335 divided by 8 equals to 41.9 part per million. As this is larger than the 30 part per million acceptable value, so this is not acceptable. The second TLV is short-term exposure limit. It is the maximum concentration that workers can be exposed to for a period of up to 15 minutes without adverse effect, and no more than 4 exposures per shift, with at least 60 minutes between exposures. For example, the TLV style for CO is 3%. The third TLV is selling. It is the maximum exposure concentration that should not be exceeded at any time. For example, the TLVC for NO2 is 5 ppm. This means the working environment should never exceed 5 ppm of NO2 at any time. If more than one toxic gas exists, the combined effect needs to be evaluated. Calculate the concentration divided by the threshold limit value for one gases and add this value for other gases. The result needs to be less than 1 for a safe working environment. Let's look at one example. The TLV selling for CO is 30 ppm, for N2O is 25 ppm, and for NO2 is 5 ppm. In a mining area, the gases concentration are CO is 15 ppm, N2O is 8 ppm, and NO2 is 1.5 ppm. Is it permitted for miners to work in this area? If we look at this gases concentration individually, so 15 is less than 30, 8 is less than 25, and 1.5 is less than 5. So individually, they are all okay, but let's evaluate the combined effect. So the total TLVC equals to, for CO concentration 15 divided by the TLVC 30 plus 8 here divided by 25 plus 1.5 divided by 5 equals to 1.12. Because this is larger than 1, this is not permitted for miners to work in this area. So in this video, we have introduced the various sources of mine gases and 3 different types of threshold limit values that is used to measure exposure levels. This is Dr. Xu. Thanks for watching this video. Please like, subscribe my channel and share. I will see you in the next video.